Hello everybody and welcome to another video. As you can see, I have many solar panels here and I'm just curious how much voltage I can get out of these when I put them in series. I just want to try them out. I got some of these just because they're not working or they're too old. I have a colibri, a honeybird, what's it called? Hummingbird. Yes, hummingbird. And this would light up and it give all kinds of colors. It goes from red to purple, the blue, the green, you know, the whole color spectrum. And it reads from this solar panel. This, yeah, it looks very dark. I think the circuit inside is broken. I have some other panels. You can mount these on the wall and you have lights, and they light until a few hours after dark. I have these are very old, also mounted on the wall, and yeah, you have a little angle here, so this is actually a very good setup. Only the angle, I think it should be even more like this. This is a better angle. It's 45 degrees, almost 60. Anyway, I want to test them all out, put them in the sun, use a multimeter to see what the current is and what the voltage it outputs. I'm not sure how I'm gonna do it exactly, but we'll go there along the way. It's also a new project for me. These were really broken, and that means even with a battery, you place the battery here, this one didn't work. Well, it could be these circuits are so irresponsible. I mean, they're bound to get corroded because you place them outside. These switches are super cheap. If the switch doesn't work, the whole circuit will not work. Yeah, you see, it's very simple diode, so the current can't flow the wrong way. We need a resistor for the LEDs, and it also has a capacitor here, and here, of course, the transistor. When this fella doesn't produce any more light, it will then diminish the transistor and it will switch to the battery and turn on the lights. It's as simple as that. So you don't need an extra sensor. This is your sensor and your collector in one. So that's pretty smart on these circuits. It's done on all these things. We have the same thing here. This just has on and off switch, battery, and this is maybe a sensor. I think this is a sensor. So when you walk past it, it senses you. And then we have a third one. I like this one. It has two panels and they're connected in series. They go to the switch. The switch is just an on-off toggle switch. The problem is this switch sometimes it's not functioning well, and you can see the screws are all corroded. So this one does not like all the water it's getting. That means the circuit can be destroyed by the water. We're gonna destroy all these things. I'm gonna take out the panels. I want to show you what's inside here. This also has an on and off switch. Also very destroyed almost. I should say you should actually remove this on-off switch and just remove the battery if you don't want to use it. This one isn't working. Why? Because this pin here is, oh, it misses. It's not going to the LED, so this one is destroyed. Too bad. Again, corrosion. I think that the wires are very cheap. These wires are useless. I'm gonna take them all apart. I'm not gonna show you that. I'm going in a bit closer. I've cut them all loose. Now we have to unsolder them. Okay, that's one. Easy peasy. That's two ones. This one's a little bit different. These are 2 panels. They're actually not in series, they're parallel. Okay, that's 2. Oh, I made a mess. Get out. Another. Maybe I should add a little bit of tin because they're very bad. Okay, one more to go. This one looks pretty good. So, this is actually a very nice one. It's came loose by itself, probably because it's very old. I have no idea how much it will give, how much power. I'm going to take this one out. So we first have to desolder the black and white cables. Whew. We have a nice sunny day, and we're gonna measure the voltage coming from these solar panels. I have a multimeter set to 2000 millivolts DC. I'm going to check the voltage. I've set the range back to 20 volts DC, and now I'm going to measure the left of the 2 panels. 3.03 volt. And the second panel, 3.01 volts. Next. First the left. This one is 2.83. And the second one is 2.63. Now the small one from the hummingbird. This one gives 2 volts 08. These panels were useless. One of them gave a little bit of power, but it's inconsistent. This one, try and clamp. Oh, this one seems dead. And this one, I think put it back. I think this has plus and minus, so that's cool. Just gonna read it. I'm not gonna place it in the sun right now. First, whoa. I direct it to the sun. There we go. Almost 5 volts. I have this fun robot standing here, and it needs 3 batteries. 1, 2, 3 AA batteries, so that's 3 times 1.5 volts when they're fully loaded. I have this solar panel I just showed you. What I want to try is hook it up to the plus and the minus of the robot, turn it on when there's enough sunlight, and see if we can make it dance, because it dances. It has some LEDs here, there, and in his eyes, and it has some motors that will make him dance. I'm curious if I can make him dance with solar power. It's a little, a fun side project. All we have to do is connect the solar panel to the back, wait till we have a nice sunny day. The last few weeks have been terrible. I'll just connect it and then we'll wait for a nice sunny day. The solar panel is on the back of the robot. I drilled a small hole in the solar panel piece of plastic. With a paper clip through it, it only works for the LEDs a little bit. It also has LEDs in its eyes, but they don't seem to work. So it's not powerful enough. What if we add some more panels to it? This has 5 volts. We have to add another 5 volts, but then parallel. I removed the solar panel from the robot, and we're going to add these 2 panels. They're going to be connected serially. Connect the minus with plus. We have one in series, and we're going to put them parallel over this one. Then we have 3 panels, and we'll have more current with the same voltage.
Hey Robo, didn't you record a video with the 3 solar panels? Well, it wasn't his fault. I forgot to make a video. It doesn't matter. You'll find out later. In the meantime, I added 2 more solar panels, and after that,
this is the fullest I can get it to work. I'm going to add one more. I'm gonna add these 2, and then we'll see. This is as much as I can get. It's gotten a little bit more. Turn the arm up a little bit. Can I create some?
let's show you what the robot should actually do. Hey, why isn't it dancing?
No music. What's wrong?
This is why. The wires to the motor were cut off, and the wires to the speakers were cut off. After reattaching the wires for the speakers together with some heat shrink tubes, I also reconnected the motor wires to the correct outputs.
Let's turn it on. Oh boy. Yes, these were just broken off or bad soldered. We're gonna close it up and see if it's differently with solar panels. Damn it. I did one thing wrong. This was the front, so I had to turn around the whole motor section. So now it looks like this. Still very nice. This arm should be in this locked spot here. Okay, this is what happens now. I have these 2. Let's see if I add those 2. It's getting more. Yeah, that's it. No motors. One final demo what it should actually be doing. This.
This was once again one of my quirky videos. I'm not done with the solar panels yet, though. I want to do more tests since I couldn't measure the current through the circuit somehow. It was nice that I could fix this robot. This project was taking a lot of space on my hard drive, and I really wanted to get this small but tiresome project out of the way and off my chest. Still, I hope you like this weird in-between video, and until next time, bye!